Okay, so what went where? Well, if you stepped through the last store in the code, you would have seen a stack that looks something like this. We have alignment for our local variables. We have alignment because of the fact that our total size of our local variables is not a multiple of hex 16, or hex 10 rather, decimal 16. And we have alignment, as we've seen, associated with our frame pointer throughout this class thus far. Then at the lowest address, we saw short a was written with the value babe. And I'm claiming here that we have int b0 here and b1 up here and some alignment in between. And you wouldn't necessarily be able to directly infer where b0 actually is. So the only things we actually see written are b of 1, and we see that written at this address, f's 8c0, and b of 4, and we see that written at 8c C. So this is basically trying to show that 8C8 would be these lower things, and on my diagrams I show the lower bytes to the right and higher bytes to the left. So 8CC is going to be the 4-byte offset from 8C8, where we will find this value, b of 4, was the result of some math that was done. And so only having the value of b of 4 and b of 1, we would have to infer, okay, b of 4 is an integer size 32-bit value here. That means b of 3 must be here, b of 2, b of 1, and then b of 0 down here. But unless you go off and change the code and change it so that, for instance, this writing of a to b of 1, if you change the code writing of a to b of 0, then instead you'll see it down here, and you'll see that there's some sort of alignment padding between the short a and the b of 0. And you could imagine, if you don't actually do that, you could imagine the b of 0 got pushed right up against the babe, and then there was 2 bytes of leftover padding here. But if you actually change the code, then you can go ahead and see exactly here. Doesn't really matter for now. I'm just mentioning it because I made a mistake in my original code, or in my original stack diagram, and that I didn't have b of 0 here. Likewise, you won't actually see anything written to b of 5, and therefore you only can realize that b of 5 is here based on the fact that b of 4 is there and the pattern is 1, 2, 3, 4, 5. So 5 should be there. And again, you have some sort of alignment, padding, uninitialized space that's never ever written to before you move on to the C. So what's the takeaway from this particular example? The takeaway is that it seems that the values are on the stack in the exact order that they were declared in the structure, except that it's basically upside down. So we have A, B, 6 integers, and then C. So A, B, 6 integers, and then C, with some amount of alignment and padding going in between things. So you could imagine that the compiler could like squish everything together and put no sort of padding in between things potentially, but we'll come back to that sort of situation in future examples. But for now, let's keep track of what we just collected, and that was the LH, load half word, SH, store half word, add IW, so add immediate to a word-sized register, and add W, add 2 word-sized registers together. Putting it like this, we got our half word and half word store and load. We've got our add IW with the compressed add IW. We've got our add W with the compressed add W, and we picked up a compressed Louis to go along with our Louis over here.